All right, sorry about that, guys. Took me just a second, but somehow when I had saved that value as b, it went away, but I think I've got it back now. So when I go back to my calculator page now, and I think if I go here and do the exact same value again, I think it now knows what b is. If I went here to this variable button and hit b there, it's got that then stored as that number. So I think now if I were to go all the way back here, and copy down that original expression here and go to copy and then come all the way back down here and try to paste it. Now that lowercase b is emboldened, so I think it now knows that the answer I'm looking for is a 0.429. And if memory serves, that was the answer that we were looking for. So a 0.429, that was going to be the answer right here to part A. Okay, let's move on to part B right here. Now they want to know the volume of the solid generated when this region R is revolved around the x-axis. So if we recall the way this worked right here, we tended to draw kind of the 180-degree reflection of this curve that would look something like this, and this thing is getting spun around the x-axis, kind of like so, to create this three-dimensional solid. Now what we can see here is that there's a big gap between this region here and the x-axis, and that means, everybody, that we're going to be dealing with washers and not with circles here. So little r, the minor radius, goes to the first curve from the axis of revolution, and big R goes to the second curve. I really wish they hadn't used the variable r here to talk about that region right there, but that's what happened, so we'll run with it. Okay, so we're talking about washers here, guys, and the formula for area of a washer is going to be pi times the quantity of capital R squared minus lower r squared. And what we're going to find right here is that capital R is top curve minus bottom curve. So capital R is that f of x function. And technically, there would be a minus 0 at the end of that, but there's really no need to put that minus 0 there. Capital R is just f of x. And then little r, right next to that, this one right over here, is going to be your g of x function, minus 0 as well. So little r is just going to be g of x. So that formula that we have right here is actually good now, and if we wanted the volume of this region, all right, it would be a definite integral, still going from 0 to b, which we wrote down before was 1.136, and unless I wrote that somewhere on my paper, I wouldn't want to use a b right here, we've got a pi that we like to put out in front of the integral, and then capital R was just going to be f of x, close it, and square it, minus little r, which was just going to be g of x. Close it and square it, and we're going to take all of that with respect to x. So let's go back to the iPad Inspire app right here and see if I can get this to work out. So we were going to begin this thing with a pi. We were going to multiply that by a definite integral that went from 0 to b, so hopefully that'll come up as bold again, and it did. Good. And now from there, our integrand, I learned a little shortcut for how to do this. We want to do f1 of x, and we want to square that. So in parentheses, I'm going to hit this variable button and go, oh, there was b there as well. So f1 of x, we want to close off the x, close off the f1, and we want to square that. So there's f1 of x quantity squared minus, and now we want to do pretty much the same thing with g of x, or f2 of x. So f2 of x, close, squared. Got it. And we're integrating all that with respect to x, and that should give us the answer we're looking for of 4.267 if we were going to round that properly. So right back over here, we're at a 4.267. And that right there is our volume for part B. All right, and let's take a look at part C here. Now in this case, it's another volume problem. The region R is the base of a solid, and the cross sections are running perpendicular to the x-axis. So maybe something that looks like this, and that is, let's see, we've got semicircles being built out of that, and this piece that we just drew in purple right there, that's the diameter of one of those semicircles, extending from f of x to g of x. So we're going to find the volume of this solid. I'm not going to draw the goofy three-dimensional rendering of this. Hopefully we're in pretty good shape. So the first thing we need to figure out right here is the length of D, which is just going to be top curve minus bottom curve. So we're just going to write that as f of x minus g of x. Now, unfortunately, the formula we're going to have to use, though, we're trying to find the area of semicircles in this particular region right here. And a formula we're going to need to know here for area of a semicircle, okay, is half the formula for area of a regular circle. So that's going to be 1/2 times pi times the radius of your semicircle squared. What that tells us is that this D is nice and handy and all, but I really need to find R. And the way we find R is by taking our diameter, f of x minus g of x, and then just dividing all of that by 2. So putting that right over here, the area of our semicircle is going to be a 1/2 times a pi, and then this radius that we just wrote down, which is going to be f of x minus g of x, all over 2. So that entire radius there in brackets now needs to get squared. And as I was grading your work on this, it wasn't surprising to me, but a whole lot of you guys made mistakes in this spot right over here. And the big thing was that not about most, but an awful lot of you guys forgot that that 2 in the denominator needs to get squared as well. So actually, it's interesting. That 2 right there really becomes a 4. And when you combine it with that 2 right there, that really puts a 1/8 out in front of this whole thing. You don't have to write it out this way, but I'm going to because I think that's going to be easier to put in my calculator that way. So again, that 2 gets squared to make a 4 on the bottom. I'm going to combine it with that 2 to get a 1/8 times pi times the quantity of f of x minus g of x. And that whole quantity is going to get squared. And so then the volume function here, everybody, is going to be the definite integral, again, from the 0 to the 1 point, and shoot, I keep forgetting, 1.136 of this a of x function that we had right over here. So I'm going to make this a pi over 8 out in front, and then right here we've got an f of x minus a g of x. Close it off, quantity squared, taken with respect to x. And let's see if I can get that to work in the calculator here as well. Okay, guys, so starting it off with a pi over 8, let's run with that. So a pi divided by 8 is going to get multiplied by a definite integral from 0 up over 2. Actually, if I click variables right there, okay, from 0 to b, got it. And then from there, in a big set of parentheses here, we are going to need to go with f1 of x, close it off, minus f2 of x. Let's close that off and close the whole quantity right there and square all of that. And we're integrating everything here with respect to x, and I think that's going to give us the answer we were looking for of 0.078 for this answer here. So 0.078. And that's the answer that we were looking for. If I'm not mistaken, I think I actually had the answers from the Real Solutions Manual right here. And I guess this is how I'll post this to you guys. So there was the answer to A that I believe we had of 0.429. Got it. For B, let's see, looks like we had an answer of 4.267, and yep, that was the right answer there, good. And for C, our answer of 0.078, sure enough, that was the answer that they had. Okay. So that's a wrap for mini quiz number 1, and I think the last slide I had right here was to show you guys this goofy grid here again. So just a couple of for instances right here. Let's just say, guys, that on a multiple choice, you got 2 of the 4 right, and on the free response, you got 5 points right there. Okay, so a multiple choice of 2 would get us right here, and a free response score of 5 would mean, if I follow this one down and this one over, that would mean here that you guys got a 4 on this particular one here. Just doing another example, maybe just for fun right here, if you had something like a, let's see, if you did real well, you did a 4 on the multiple choice right here, and you did really badly on the free response, and you only got like a 3. All right, 4 on multiple choice, 3 there. That still ends up being a 5. for the entire thing. So as you guys can kind of see from the chart, if you do really well in one of the areas or the other, it tends to really help you out here. So okay, hopefully that's helpful. Let's give mini quiz 2 a try, and I'll try to post the answers to that sometime maybe on Friday or over the weekend.